this concept, uh, how to create a value stream map. So how this value stream map looks like. So when Toyota developed the value stream map or V.S.M, so they're trying to use certain predefined symbols to create what is happening in the process. So the information flows can be seen, material flows can be seen, and the time taken in the process, the time ladder, help us to understand the time taken in the process. So three things can be studied in a value stream map. So this is the predefined symbol. So the information flow, how it happens in the process, the customer to the production control, how it in the process. So in the organization, so the production control department of the process, the information is flown from the customer. So customer gives a monthly order to the production control, which gives a weekly order to the supplier to the raw materials. So there is information flow happening, and how the material flow happening in the process is being established here in the value stream map. So there are uh, three processes involved, and finally shipping is happening. Supplier weekly transport the raw materials to process A, which is used by process A, and give it to the process B, and then the material is given to the process C, and then the shipping is done to the customers. So the inventory is given here. The number of inventories is given in the triangle, and the number gives uh, the inventory numbers are given. So 1883 is the inventory given to process A. So the cycle time of the process is given here. Changeover is from a manufacturing perspective, from one batch to another batch, when the changeover need to happen. So what is the time taken for the machine to start the next is called a changeover time. Uptime is how much time that equipment is available for work, or that is 80% of the time this uptime is there. 20% of the time it is not available for the work. So we call it the uptime is 80%. Two shifts are there for that process in the industry or in the company. And this is the per shift, what is the seconds available, or the available time for each shift is being given here. So process B also, the cycle time, the changeover time is given. Process C, the cycle time, and what is the inventory between the process step on an average, what is the inventory seen by the process is being given. So the project team look into the process and see what is the time taken for each item to be processed. That's called a cycle time, on the changeover times are given. And we are looking into what is a cycle time and waiting time between the process time. So we say for 6 days for procuring the material, and process A take 300 seconds for one item to be processed. And on an average, a product waits for 4 days to get into the next process, which takes 45 seconds. And on an average, a product waits to 1 day to get into the process C. That is 240 seconds is the time taken for. So when you look at the processing time for one item to be processed by process A, process B, and process C, it is 585 seconds. But when you look at the waiting time or the production lead time between from the time we are looking into this, so we can say it as five. So it is 14 days which has been looked into. So that is 14 days is the production lead time from procuring the material to shipping the material to the customers. So it takes 14 days is the production lead time from procurement to dispatch and the customer receiving it, the total production lead time. So this is called as a time lead time ladder, or the time ladder. The bottom gives the ladder of the bottom, gives the cycle time of the process, and the waiting time between each process is given as the waiting time is given on the upper ladder, and the total lead time and the process timing can be calculated by looking into the team ladder. So this is the three things that we can study in a value stream map: the information flow, material flow, and the time ladder, helping us to understand what is the time taken for process. So once we look into the value stream map, then we look into a micro level process map. So when we look in a micro level process map, in this, we are not looking into the detailed steps in each process steps. So each process A, process B, process C, we are just looking into what is the different processes involved. In a micro level, whatever those steps that we are defined, so each step is added in detail. So we look into the process and give it micro level process map. So that in a SciPog, we were just writing 5 to 7 steps, but in a micro level process map, we are writing each step in detail. So when we create a micro level process map, we go in detail of each process step and look into those each process step and write it. So this is this for your understanding that there is no limitation in the number of steps when we create a micro level process map in contrast to a SciPog or a macro level process map. And we can see multiple endpoints will be there for the start and the endpoint. Multiple endpoints will be there in a flow chart in which we create as a micro level process map. Here we say we receive the order, we check the order if it is valid. So here the decision boxes are used. In a SciPog or the macro level process map, we don't use decision boxes are not used. Is it valid? No, we cancel the order. Yes, we confirm and sign the order. Check if there is enough stock. Yes, we check the quality of the products. If we don't have a stock of the order, then we procure the materials and make the products and do the quality check of the products. If you have enough stock also, that is a yes goes to the quality check. Is quality is good, then we pack the product, deliver the product, and the customer receive the product. If the quality is not good, then it becomes a scrap. So this is a micro level process map. We can again give more details on procurement of materials or making the products. We can have more steps for the. I've just wanted to show you that how a micro level process map is written using a simple flow chart. So multiple each step in detail we can write in details and write a micro level process map. So it is up to the project team to see the process and observe the process and create a micro level process map. So that is the second step of it. So once we create a value stream map, which is more of a systematic, or we look into more of a system level understanding what is information flow, what is the material flow, and how much time are we taken in the process. Here in a micro level process map, we are going to go in more detail of the minute details of each process step. And then we also do a time motion study to do what is the time taken for each process step. We call it the process time. And what is the waiting time between the two process steps. And the cycle time is going to be the total process time plus total waiting time becomes a cycle time of the process. So when I look into each process, it will have multiple steps. So we try to see what is the time taken for each step. We call that as a process time. The waiting time is the time taken between two process steps. And the total time taken for the process, we call it the total process time. And total waiting time give us the cycle time of the process. So it is called as a time motion study. So once we look into the micro level process map, we try to see what is the time taken for each process step and what is the waiting time between the process step. When we have together all this time, then we can say what is the cycle time of the process by looking into the total time of total process time and total waiting time of the process. That's why we create a process map. So this is what is the lean part of measure phase, where we create a value stream map, we create a micro level process map, and then we do a time motion study to understand the process time and waiting time between the